Good morning, children. We proceed doing problems based on binomial expansion. Exercise 5.1, question number 3. Using binomial theorem, indicate which is larger. 1.01 the whole power 10 lakhs and 10,000. As we see, 1.01 the whole power 10 lakhs. Count and put the zeros properly. That is 1 plus 0.01 whole power 10 lakhs, which can be written as, we know first term C0 will come, NC0 model, so it is 1 only. Second term NC1, that is 10 lakhs. C1, so that is 10 lakhs into 0.01 power 1 will come, because first term is 1. 1 power anything when I write it is 1 only. Second term, first time power 0, second time power 1 and so on. This is nothing but 1 plus 2 decimals, 2 zeros will get cancelled. I get 10,000 plus and so on. It is 10,001 plus some value, which is definitely greater than 10,000, because first two terms itself give us 10,001. We need to compare with 10,000. So obviously this expansion is larger. Therefore 1.01 the whole power 10 lakhs is larger. Let us remember the expansion when it is 1 plus x the whole power n. 1 plus nx plus nc2 x square and so on till the last term ncn x power n. We have first term to be 1. 1 power anything 1, so we don't write it. NC0 is 1, NC1, NC2 and so on. Only the second term will come since the first term is 1. And that is what we have used here. And I have stopped with 2 terms because it goes up to 10 lakhs terms, which is difficult to write. Our question is not the exact answer, but just a comparison. So first 2 terms are sufficient enough to declare this expansion is larger. So we are ignoring the remaining terms. Question number 8. Find the last 2 digits of the number 3 power 600. Such an interesting question. When people find too difficult to find even 3 power 6, we are given 3 power 600. And the question is to find what would be the last 2 digits if I expand this number. How are we to do it? Anything with powers of 10, 100 will be easier. So, how shall I rewrite this 3 in terms of 10? Let me say, 3 power 600 can be rewritten as 3 square power 300. Can I write it? 600 I have written 2 into 300. 3 square is 9 power 300. Now 9, something easy for me to write as 10 minus 1. Now it is a binomial expansion. How shall I write it? 10 minus 1, I will write the power is 300. So 300 C0, 300 C1, 300 C2 and so on. The last term 300 C 300. First term 10. So 10 power 300, 10 power 299, 10 power 298 and the last will be 10 power 0. First term keeps on decreasing. Second term keeps on increasing. 1 power 0, 1 power 1, 1 power 2 and 1 power 300. When I see 300 see 0, 1, 1 power 0 also 1. So it is 10 power 300 and the terms go on and on. What is the last term? Because this is having more zeros. My idea is last two digits. So I am bothered about these terms. 1 power 301, 10 power 0, 1, same number comes, this is also 1. So what is the last number? 1. What would be the previous number? Let me think and write. What would be the previous number? 300C, previous number would be 299. 10 power 1, 1 power 299. The previous number 300C 298. 10 power 2, 1 power 298. So the expansion goes like this. 10 power 300 to this power 300C. When the numbers are big in combination, remember we used to subtract. Remember the formula, NCR is NC N minus R. So 300C, subtract, it becomes 2. Into 10 square is 100. 1 power anything, 1. 300C, subtract, it becomes 1. Into 10, 1 power anything, 1. Plus 1. If I combine these terms, all are multiples of 100 only, because 100 and more powers. So all these are, I can say, multiples of 100. So they will not affect my answer. My question is last two digits. So multiples of 100, let us forget. Coming up here, 300C1 is 300 into 10 plus 1. So this is implying the last two digits will be last digit 1. Little before that I have 3000. So 10th digit is 0. So my question is last two digits. I get 0 and 1. Last digit 1, previous digit is 0. The remaining fully will be multiples of 100. They don't affect my last two digits. My question is last two digits and I end with my answer as 0, 1. Question number 9. If n is a positive integer, show that 9 power n plus 1 minus 8n minus 9 is always divisible by 64. My question starts with 9. Usually 9 comes, I will write 10 minus 1 for the expansion. But here my question is divisibility by 64. The same problem we can do using mathematical induction from 4th chapter. But now we are going to do the same using binomial theorem. Because 64 is coming, I need to write it in terms of 8. So 9 is written as 1 plus 8 whole power n plus 1. Remember the formula 1 plus x power n. 1 nx n c2 x square n c3 x cube and so on n c n x power n. Whenever first term is 1, we can remember this easy expansion. Only the second term keeps on increasing in power. First term being 1. 1 power anything 1 can be ignored. Now, if I apply this here, it is 1 plus nx. Here it is n plus 1 into 8 plus nc2 x square. N plus 1 c2 8 square. Next term n plus 1 c3 8 cube and so on. Last term will be 8 power n plus 1. Ncn is 1, so I can ignore. Now, if I multiply 8 into n plus 1 into 8, we are just multiplying this bracket alone. The remaining I am not going to multiply because these are 8 multiples. 8 square, 8 cube and so on. So naturally divisible by 64. Why do I say divisible by 64? Multiples of 8 square and so on. So here I have 9 power n plus 1. Bring it to the left. 9 power n plus 1 minus 1 minus 8n minus 8 equals to. I have brought these terms to the left. So the remaining terms we will say divisible by 64. Why do I say divisible by 64? Since multiples of 8 square. First term 8 square. And after that it is 8 power 3, 4 like that. So multiples of 8 square tell me they are all divisible by 64. So I am left with 9 power n plus 1 minus 8n minus 9 is divisible by 64. So instead of doing induction procedure, I can also use binomial theorem to prove the result. Question number 12. If a and b are distinct integers, prove that a minus b is a factor of a power n minus b power n whenever n is a positive integer. The same idea as the previous one. My question is a power n minus b power n. I want a minus b. So a, let me write minus b plus b the whole power n. I am writing a power n as a minus b plus b the whole power n. You have the second term minus b power n equals to. Let us expand. Keeping a minus b together. What expansion? It is a plus b the whole power n. What is my formula? First term nc0 a power n b power 0 nc1 a power n minus 1 b power 1 and so on. Ncn a power 0 b power n. In this problem, in the place of a, I have a minus b and in the place of b, it is b only. So instead of a, I am going to put a minus b. So in the same expansion, let me start. nc0 a power n. So what should I put? A minus b power n b power 0 plus nc1 a minus b power n minus 1 b power 1 nc2 a minus b power n minus 2 b power 2. What is the last term? Ncn a minus b power 0 b power n. We have completed the expansion. You have one more term minus b power n. The next step. nc0 is 1, b power 0 is 1. I am left with a minus b power n. nc1 is n. a minus b power n minus 1 b. nc2 a minus b power n minus 2 b square. Last term I have ncn is 1, a minus b power 0 1 I am left with b power n. Here I have minus b power n. It is good that we write the previous term. What would be the previous term? Previous term would be here power 0. Previous term will be a minus b power 1. B power n minus 1. NCN is 1. Previous term will be n. Now b power n cancels. In all these terms, a minus b is coming. So I can say it is a minus b into a minus b power n minus 1 plus n into a minus b power n minus 2 and so on, n into b power n minus 1. So it is a minus b into something. Therefore, I will say it is divisible by a minus b. Instead of telling divisible by a minus b, I can also say like this. A minus b is a factor of, whenever I say it is divisible, the other words to say a minus b is a factor of a power n minus b power n. So these are skillful problems just having in 2 lines. What you need to remember is the very first step. My question is a minus b is a factor of what? A power n minus b power n. Write a power n as a minus b plus b because I want a minus b. So whenever I put plus and minus, it is not altered. The whole power n. Now, a minus b I consider as first term, b I consider as second term. We know the expansion in which I am substituting wherever a comes as a minus b. Wherever b is coming, I put b only. Wherever n is coming, I put n only. So as I substitute, I have last term b power n and this minus b power n getting cancelled. Immediately you can write every term is having a minus b. Therefore, a minus b is a factor of a power n minus b power n. This is just an extra step. If you need, you can write. Otherwise, you can directly write this is divisible by a minus b. Question number 16. C0 square plus C1 square plus C2 square and so on up to Cn square equals 2n factorial by n factorial the whole square. When I look at this combination coefficients, remember the expansion 1 plus x power n. What is the formula? 1 or I can say nc0 plus nc1x, nc2x square, nc3x cube and so on up to ncn x power n. This idea rewritten as instead of nc0 we write c0, nc1 I write c1, nc2 we write c2 and so on up to cn x power n. In the same way, I want 2n in this question. So what is 1 plus x power 2n? How will I write it? It is 2n c0, 2n c1x, 2n c2x square, 2n c3x cube and so on. The last term 2n c2n x power 2n. My question is, I want n factorial. So let me take what is coefficient of x power n, because x power n only comes here. So what is coefficient of x power n in this? Check. If it is power 1, 2nc1 is coming. If it is power 2, 2nc2. If it is power 3, 2nc3. So if I want x power n, it will be 2ncn. How will I expand? Let me remember the formula NCR. N factorial by n minus r factorial into r factorial. In this question, n is 2n and r is n. In this question, n equals to 2n, r equals to n. So, the same formula I am going to apply, but wherever n is coming, I will put 2n. Wherever r is coming, I have to put n in this formula. So, n factorial will become 2n factorial by n minus r factorial, 2n minus n factorial, r factorial is n factorial. So this is the formula we learnt in combination. Wherever n is coming, I am putting 2n. Wherever r is coming, I am putting n. So this becomes 2n factorial by n factorial into n factorial, or it is n factorial the whole square. This is number 1, let me say. Now 1 plus x the whole power 2n can also be written as 1 plus x power n into 1 plus x power n. Can I write it? Because it is saying n plus n is 2n. I want squares. So I need to multiply this again and again. How shall I multiply? What is 1 plus x power n from here? C0, C1x, C2x square and so on. Cn x power n. What is 1 plus x power n? Again repeat it. C0, C1x, C2x square and so on. Cn x power n. We know NCR equals NC n minus r. That is, I can reverse the coefficients. Front to back, back to front, they are one and the same using this combination property. So, this will be C0, C1x, C2x square and so on Cn x power n. Here, I am rewriting. So, it will become C0 x power n, C1 x power n minus 1, C2 x power n minus 2 and the last is Cn x power 0 because I am rewriting. So, Cn x power n will now become Cn x power 0 because we interchange the coefficients. The next step, I want to find coefficient of x power n. So what is coefficient of x power n? How am I going to find the coefficients? If I take C0 here, no x power at all, combine this. Here x power 0, here x power n. Combine these two. X power 1, x power n minus 1. Combine these two. X power 2, x power n minus 2. Like that, I will combine this. So, in all the cases, if I want coefficient of x power n, C0 into C0, C0 square, C1 into C1, C1 square, C2 into C2, here power n minus 2, here power 2, C2 square and so on. At the end, Cn into Cn, Cn square. So, this is LHS of the problem and this is RHS of the problem. So, I call this as 2. 1 equals to 2 implies, because in both the cases I am finding only coefficient of x power n. So, from 1 and 2, I am able to conclude C0 square, C1 square, C2 square and so on up to Cn square is 2n factorial by n factorial the whole square, and hence the problem.